Welcome to the IM2 video lecture. This is going to be covering the Unit 2 Polynomial Operation Review Sheet for the exam. This video will be covering page 1. Number 1 asks us to simplify all these rational exponents inside these radicals. What you need to understand is the radical represents a 1/2 exponent. So radical x, or the square root of x, is equal to x to the 1/2 power. So this is what you want to do here. First of all, I'm going to split this into two parts. I'm going to split this into the square root of 4 times the square root of x squared. I can plug this already in my calculator and get the value 2. Now I want to deal with this. It's x squared, but now I want to divide it by 2 because that is what the radical is. Because I can simplify this now. It becomes 2x. 2 over 2 just becomes the value of 1. So the final answer would just be 2x. Let's look at B. Same process. I'm going to split this into two parts. The square root of 25 times the square root of x to the 4. The square root of 25 just becomes 5. Multiply x to the 4th divided by 2, because that's what the radical represents. You get x to the squared, because 4 divided by 2 gets you 2. And the 5 was in front, so the answer would be 5x squared. What happens if you have a 3 on top of the radical? Well, the 3 on top of the radical is the same thing as the cube root. So we can write that as to the 1/3 power. So split this into its two parts. Radical 9 cube root times cube root of x to the cubed. Alright. If you want to plug this into your calculator, make sure you're typing in the cube root of 9. Or you can write this in its exponent form, which is 9 to the 1/3 power. And you could put that in your calculator if you want. Times x to the 3rd divided by 3. You plug this in your calculator, you get 3. X to the 3 over 3 just becomes 1. So this simplifies to just 3x. Same process here. We want to split this into their two parts. The cube root of 64 times the cube root of x to the 9. 64 to the 1/3 power times x9 divided by 3. If you plug this into your calculator, let's see what that becomes. This is your cube root, so this becomes the value of 4 times 9 over 3 just becomes the value of 3. So we can say the answer here is x is 4x cubed. Now we have these expressions here, and they're asked to which value is equal to the following expressions. Well, let's just plug this into the calculator. If you plug in 4 squared into the calculator, you're going to get 16. If you plug this into the calculator, you're going to get a weird decimal. So what you need to do is think about how to turn this into a positive value. We know that this is really over 1, and this is a negative exponent. And we know we can flip it, and it changes the exponent. So it becomes 1 on top, on bottom, it becomes 4 to the 2nd power. And we know that this, from the first problem, is equal to 1 over 16. What happens if you have 16 to the 1/2 power? Well, if you plug that into the calculator, you should get the value of 4. Okay. You should see there is a connection between C and A. All right. Then next, let's do B. I'll make this purple. If you plug this, oh, it's a negative exponent. So make sure you bring it down of the fraction to turn it into 1 over 16 to the 1/2 power, which is going to be equal to 1 over 4. Okay. So make sure you're able to make it into a positive exponent first, then simplify. All right. So you can say x squared, you could say 4 squared, or you could say 16. You could say 4 to the negative 2 power, or you could say 1 over 16. Same thing here, but now we're working with the value of 3. If you plug this into your calculator, you get the value of 9. 3 to the negative 3 power, we know we don't like that. So we are going to, like I said, flip it. And flip it good by changing the exponent. So you have 1 over 3 to the 3 power now, which is equal to 1 over 27. I do not know why I keep putting 9 here. This should be 27. Okay. Because it's 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Okay? You see, even I make mistakes, so make sure you can catch your own. That's why we should use a calculator. Alright. Let's take a look at 27 to the 1/3 power. If you plug that into your calculator, you should get the value of 3. Okay? Please notice C and A are connected somehow. Now, what happens if we have something like this, which is a negative exponent? Well, we know that we have to, like what we did from before, we have to flip it. So this becomes 1 over 27 to the 1/3 power. And we know that 1 over 27 to the 1/3 power was equal to 3. So this is 1/3. All right. That is how to do 2A or 2B. Next, this asks us to match the expression with the correct polynomial that describes it. First of all, let's look at a monomial. A monomial, by definition, is one term, and it is going to be equal to, is it 25? No, it would be 2x cubed. Okay, that is one term. Now you're wondering, wait, Mr. S, what about 25? Well, 25 here is actually the constant. The reason why is because that is just a number. Binomial, 2, that's in its name. Bi stands for 2. This has two terms, x squared minus 4. Lastly, we have our 1, 2, 3, which is 3 terms, which is going to be our trinomial, which is going to be right here. There you go. So that matches us up. A is your binomial because there's 2 terms. B is your constant term. It's just a number. That's green. C is your trinomial, which is in red. And this one is just one term, so it's one monomial. All right. Let's look at 4 here. It asks us to describe the following polynomial. Let's look at the first, the leading term. The leading term is the number in front, so it is the entire thing. The leading term is the entire thing, so it's 2x squared. Okay. the leading coefficient is only the number in front. Okay. So the leading term is 2x squared because that's the entire thing. The leading coefficient is just this number. So it's only the number in front. Get it? Leading term is the entire thing. Leading coefficient is just the number. Now let's look at the degree. The degree is the highest exponent. So it is 2 as the highest exponent. Then the constant is just going to be the number. People put 5. You're wrong if you put 5. It's not 5. It's negative 5. Okay? Because it has to be the entire value here. Right? Let's take a look at B now. Leading term. What is the number in front? What is the number in front with everything here? It is 2x squared. Okay. What about my leading coefficient? Well, it's only the number in front, which is 2. What is my degree? Well, my degree is just the number on top here, which is just 2. And what is my constant term? Wait, what is my constant term? Uh-oh, this is not in standard form. Haha. So my recommendation is to put this into standard form first. So I'm going to move this up, put this into standard form. So I have 2x squared. I have right here 7x minus 2x. So I have plus 5x. And I'm going to add 4. Wait, notice it didn't change any of the answer. The leading term, it's still 2x squared. The leading coefficient, it's still 2. The degree here, it's still 2. It's still 2. Look, still 2. The constant, it's the number. So make sure you get that. This is the constant. So it's 4. This is the constant. It's just a number. All right? Good job. But notice the leading term, the leading coefficient, and the degree did not change. Let's look at 2. Uh-oh, that's not in standard form. So let's put it in standard form. Well, the x squared has to go first because it has the highest exponent. Then we add the 9x because that has 1x. Then we add 4 plus 2 got us 6. Good. Now we could look at our leading term. Remember, the leading term is the number in front. So it is x to the second power. It's just this. What is the leading coefficient? What is the number in front? It is the answer 1. There is actually a 1 in front here. But do we ever write the 1? No. But it does exist. The 1 does exist. What about the degree, though? The degree is the highest exponent. And the highest exponent here is 2. So 2 would be the highest exponent. Then what is the constant? Well, we said it was 6 because that is 2 plus 4. Make sure you add them. 4 plus 2 is 6. Do not just write 4. It's 2 plus 4. Right? So I want you to take a look here at these 3 problems. Let me move this down so you can see it a little bit better. And I want you to take a look at how they are, let's say, similar in some ways. Right. Notice that A and B, the leading terms are the same. The leading coefficients are the same. The degrees are the same. The only thing different is their constant. A has a negative 5 as the constant. B has a positive 4 as the constant. Okay. Next, Same thing with C. We notice that they all have a degree 2 here, right? And we have to make sure we had a change, put it in standard form. Good. Now we can do number 5, which is to simplify and write the expression in standard form. Well, here they just ask us to add. So let's just do that. Let's just add them. I'm going to color code this so we can see it a little bit better. We have our parentheses 2x squared plus 2x squared. I'm grouping this together. This is my x squared. Then I'm going to add this to my x terms. So 4x plus 5x. Then I'm going to add this to my constant terms, which are 2 plus 1. So 2x squared plus 2x squared gets you 4x squared. Then 4x plus 5x gets you 9x. 2 plus 1 gets you the value of 3. And they all have addition right here. So your final answer would be 4x squared plus 9x plus 3. Perfect. Good job. Same thing from here, but now there's no parentheses, but yet they ask us to simplify this. So let's do that. Let's organize them together. So we have this, which is an x squared, and we have this as an x squared. So I'm going to write that down. 7x squared minus x squared. Okay, that's why I color coded so you can see it. Then we have our negative 13x and plus 3x. Then our last one is our constant term, negative 5 plus 2. Now we can add it. 7x squared minus x squared. Remember, there's technically a 1 here. So this is 6x squared. Let's go to our x term. Negative 13x plus 3x is negative 10x. Then lastly, we have negative 5 plus 3. That gets us negative 3. So this is actually our answer right there. 6x squared minus 10x minus 3. Good. Let's do B here. Let's group all the terms together. X squared, x squared. So we have x squared plus x squared. Then we have our second term, which is, just our x. There's two x's here. So that is negative 10x minus 2x. Then lastly, we have our constant term. There's only one constant term, which is just 4. Let's add them. X squared plus x squared gets you 2x squared. Remember, there are number 1s in front. Then we have negative 10x minus 2x. Okay, plug this into your calculator. Gets you negative 12x. Then you have your plus 4 here at the end. There you go. Yes, I know I made a mistake. I made this letter B and this letter B, so please be patient. Let me group these together so you can see it a little bit better. Right, good. Now we are going to do 6. 5 had us adding and simplifying. 6 has us subtracting. Let's do that. Well, we hate that negative. We really do. So what we can do is distribute it. We can distribute that 1 across to each term. So negative times x gets you negative x in the parentheses. Then you get negative x times 4 gets you negative 4 in the parentheses. All right. What's left out is a addition now. So we can write this as 3x plus 5 plus negative x minus 4. All right, so let's subtract. Our first terms are our x terms, so 3x minus x. Then we have our second terms, which are constants, which is going to be 5 minus 4. What you have here, 3x minus s, gets you 2x. Then you have 5 minus 4, which just gets you the 1. So the final answer would be 2x plus 1. Let's do B. Uh-oh, there's also a negative. We have to deal with it by distributing it over. This becomes negative 2x. Distribute the negative over to the second term. Gets us negative times a negative, gets you a positive. So this is positive 4x. Then distribute the negative to the 5. Gets you a negative 5. Great job. Bring everything else down. 5x squared plus 2x plus 2 parentheses. And we know that we add here. Alright, so let's combine our like terms. Well, we have our 5x squared minus 2. Oh, we don't. Uh-oh. Notice that this is not actually x squared. So that's it. This is all we have for our x squared term. What about our x's now? So I made that blue. So I'm going to add. I have 2x here. I have a minus 2x here. Look, I also have a plus 4x here. Wow. This time they had 3 x terms here. 2x minus 2x plus 4x. Wow. Then our last term was our 2 minus 5. All right. Nothing happens here, so it's just 5x squared. What about our blues? 2x minus 2x got us 0, leaving us with a 4x right here. Then lastly, we have 2 minus 5. That got us negative 3. There you go. That's your answer. 5x squared plus 4x minus 3. All right? Good. There's no error here. This problem just indicates sometimes things can simplify and you could have more terms than just 2. Let's do C now. Oh, it's in parentheses and it's a subtraction. Well, we know what to do. We have to get rid of the negative by distributing. Negative times 2x gets us negative 2x. The negative times the 5x gets us negative 5x. And the negative times the 5 gets us negative 5. And put this into parentheses. And now the outside is an addition. Good. At this point, we can now combine our like terms. We have 6x squared minus 2x. Then we have our blue, which is going to be negative 5x here. And we have a negative 5x here. And in the end, we also have a 2 here minus 5 here. All right. So again, I'm just writing it on basically how I see it. 6x squared minus 2x. Oh no, this is wrong. So this is not correct. This is staying alone. Okay. The 2x was actually right here. I was missing something here. I was missing the blue here. Haha. Negative 2x. Wow. So remember, there were 3 terms for the x's. A negative 5x, minus 5x, and a minus 2x. Be very careful here. See, I almost made the mistake, but you can catch it. So, anything happens to the red? No, it stays at 6x squared. What happens to the blue? Well, we have a negative 5x, minus 5x, and a minus 2x. Together, that got us negative 12x. And what about 2 minus 3? Well, that just becomes negative 3. That looks like our previous problem. So, let's bring that together so you could see it a little bit much better. Notice that it is like our last problem. But this time, we had, again, the x terms are both inside here. So be very careful, all right? But good job. If you did not make an error like me, you did really well because you're smart, right? So, good job on figuring this out. Here is a way for you to double check your answer, right? Make sure your answers match up with mine, unless I have some errors, right? Good job. Okay, and that is it for the first page.